Perfect. Hello, everybody. This is what is this? October installment of the Microsoft Data Platform Continuity Virtual Group. Thank you all for joining. With me today is a phenomenal individual, long-term friend, Brandon Leach. He is going to be talking about a DBA's guide to the proper handling of corruption. And point blank, not only do you need to know how to do this, you need to practice this because it's not a matter of if your critical databases will ever get corrupted. It's simply a matter of when. These things happen. And you don't need to be Google searching for commands in the event that you actually have this happen. So study this. Ask any questions, throw them in the chat window. And with that, I'm going to turn this over to Brandon.
All right, thank you, David, and welcome everyone. So, a little bit about me. I am a Microsoft Data Platform MVP and a SQL Server infrastructure architect for a major hedge fund. I'm also a lifelong learner. I was the kid that my parents would get a new TV, and 2 days later I'd have it disassembled on the floor. They weren't too happy about that, obviously, because then I would ask them to put it back together. I've been involved with various events in the community, both speaking and organizing. And yeah, I just love to learn new things and how things work and how to break them in interesting ways. So today we're going to talk about a couple things. We're going to talk about physical corruption, what that means for you, how we can monitor for it, how we can deal with it as it comes. Now, if you've already dealt with corruption incidents, this probably isn't necessarily the best session for you. This is meant as a beginner level to help people avoid making some of the mistakes I made when I first learned this stuff at 3 a.m. in the morning. Because that's always everyone's first corruption experience. Your phone goes off, it's 3 a.m., you're groggy, you've never seen any of this before, so you're rapidly Googling, you take the first thing that comes along, and it turns out to be the wrong move. And it makes your situation worse. It makes recovery harder, right? This is what I want to avoid. So we're going to talk about various things, including incident management, postmortems, finding root cause. We're going to talk about the tooling available in SQL Server to identify corruption early. And then we're going to go into what to do when corruption happens. Now, I am reworking these slides a little bit, so if you see some things out of place, please bear with me on those. So the first thing we have to do is we have to define database corruption. Now, for our purposes, we're going to focus on physical database corruption. What do I mean by that? Well, we mean the physical bits in the files have been altered. We don't mean that the patterns inherent to your data have changed, right? So for physical database corruption, we're talking about the files themselves, not the data within those files necessarily. Now, a physical corruption will change values in your data, but it will have a larger impact against your ability to retrieve that data. Regardless of what type of data what type of corruption we're talking about, however, it is important that you understand that resolving it, identifying and resolving it immediately will actually help you to avoid the problem becoming much bigger as it goes downstream to other systems. So, David kind of alluded to this earlier. He said, you're all going to see corruption at some point, and if you haven't. Unfortunately, I've seen corruption way more than I really want to admit. I worked with one company that had 1,800 instances of SQL Server, 20,000 databases with 200 new ones being created per week. That's a large environment. Bad things are going to happen as a matter of course. And during my time there were about 3 or 4 corruption incidents per year. So your mileage may vary, but you will see it. I've seen it at almost every company I've worked at as a DBA. So we have to accept that that's going to happen. That no matter what we do, it's going to happen. And so we need to be proactive about it. And that's where our tooling comes in, our monitoring. The protocols that we'll talk about, those are how we respond to it when it does happen. These are things like, who do we need to get on the call? Who makes the decisions versus who executes the tasks, and who makes the recommendations, right? Also, how we document and learn from this and make our environments better and more stable. So normally when I do this in person, I like to ask people to point out to me where in these two images corruption can occur. On the left, we have a typical server. Could be hosted in a hypervisor, or it could just be a bare metal machine. But typically, once you get to the hypervisor, it's connected to switches, which are connected to SAN controllers, which have redundant connections to the disk arrays. Internally in the OS, however, you'll typically have the database engine, which sits on top of the OS itself, which has local storage. And that storage may be RAID, it could be spinning Rust, or it could be flash-based storage, NVMe, something like that. Does anyone want to pop into chat and say where they, or even just unmute and say where you think corruption can happen in here? I'll give it a few seconds. I see one person in chat. Yeah, David, you are absolutely correct. Everywhere. One of the interesting things about complex systems is the more complex a system, the more likely you are to have an issue, right? So each of these components that you see is a different layer of complexity, and everything you see over here is a different level of complexity. Now, what we see over here on the left, by having all this redundancy, we decrease the risk of an outage, but we have more components that could break, that could create an error, and those errors could lead to corruption. Corruption happens, but it doesn't just happen, I like to say. So, this is why it's often better to keep things simple, right? When we talk about designing our systems. And I don't say that to mean don't add redundancy. Absolutely add redundancy where it makes sense. So Larry is asking, what is a SAN controller? So let's go back to that. Give me 1 second. All right. So obviously the switches are network switches. SAN controllers are essentially an interface for communicating with everything else in the SAN. Most specifically, the disk arrays. They will receive incoming packets, requests for data. They'll go and retrieve that data, send it out to you. Your SAN is always going to have a couple of these. Also, you might connect to your SAN through an interface, which will in turn connect through the controllers to get data about what's going on. I'm oversimplifying here greatly, and if there are any storage admins on here, I apologize. But yeah, generally they are the interface into which the rest of the network connects. And so typically if you're going to update one, you will put one into maintenance mode so that all the traffic comes over to here, and then you have your high availability. I hope that answers the question. Oh, we might have one more. You're welcome, Larry. I'm just going to leave this up and over here so that I can actually just look at it a little bit. So SQL Server has some tools for monitoring for corruption. Built in right out of the box. As soon as you install it, you have access to these things. Now, they're not the most robust, but they cover a pretty good base. And the second one you see listed there, CheckDB, is something that every DBA absolutely needs to be familiar with and using. But the first and the third, I like to refer to as kind of frontline, right? These are actual monitoring, whereas CheckDB is more quickly tell me if there's corruption. It's more ad hoc in that sense. So the first two I'm sure you've heard of. The bottom one you may not have. Sorry, my mouse doesn't. It's clicking out. So is anyone here using SQL Agent Alerts? Just toss it in the chat if you are. I love these things because even if you have no actual monitoring software, you can put this in place and you can get emails sent for critical events or errors straight to your PagerDuty or whatever it is you use to page folks. So we can be notified of not just errors, but also severities. So if we want every severity 18 to message us, or let's go with 25 instead, because that's super critical. This, all we have to do is say severity 17. We don't have to list every single error number. But also, if there are specific errors you care about, whether it's for corruption or you just want to know when a user gets that error number, you can set that up. And in fact, I do one of those. I monitor for error 666 because I've hit it in production and I never want to hit it again. That is a whole internals discussion, so we're going to put that off to the side. But we generally we want to understand and monitor at least for severity levels and one specific error number when it comes to corruption. We also need to understand that as we go through the severity levels, that the higher the number, the more severe it is. Anything 19 to 25, you probably want to take immediate action on and at least look at what's going on. Certainly once you get to like 20 and above, or sorry, 21, 22 and above, you absolutely need to be in there immediately. But it doesn't alert on these things until you set it up. So let's go and look at Agent. And I'll walk you through how you create one of these. Where is my... There it is. So this is just a SQL Server on my local desktop here. If we go over to SQL Agent, we'll see we have no jobs, but we do have all of these alerts. And you'll see I'm monitoring for everything from severity 17 through 25. And here's the nice thing. I have a script right here that you can literally just run, and it'll create all these alerts for you. So, for example, we're just calling SP add alert. This is a 825 read retry required alert. What read retry required means is that you can, or sorry, SQL Server tried to read from memory and failed. So it tried to read again, and it got the data. What this often means is that you likely need to do a diagnostic on your memory modules. You may have memory failing, and that can lead to corruption. It can also lead to failed critical jobs, obviously, and all sorts of other things. So if I got that error, what I would immediately do is I would have that routed direct to the hardware team, so that they could go and run the diagnostics that they need to. I would also fail any activity off of that box. So when we want to create the rest of them, it's just calling the same thing. It's just, you'll notice the difference between these two, is that we're using message ID here, and we're using severity here, right? So this script, which I will send to David, is literally going to create all of them for you. You can just run this, and you'll have all these alerts show up here. Now, there's also this thing called operators. So if you're not using agent to send out pages, and you want to, you would simply come over here, you'd create a new operator, you'd give it a name, and you'd fill out details like email, etc. You can also set times of when to alert that individual, but generally I would just say all the time. Then once you create the operator, you can also right out of here, you can have it send all the emails. We can just check this, and it will send those emails. And as long as you have DB mail configured and set up, you will start getting paged for these events. Now, if I wanted to create the 666 one that I mentioned earlier, I would just change this to 666. So real nice, easy to set up and get some basic alerts. Now let's talk about what these severities are. And I just need to go here. Did that slide get hidden? I just need to check and see if a slide showing all the severity levels got hidden. So give me 1 second. I don't know why it's not in there, but I do know it should be in here. So here it is. I'll show it to you right here. Right? So now we start off monitoring error or severity 17, and that just means that some limit was reached. It's not corruption, but something you probably want to look at whatever that query was that was running. You know, a non-fatal issue in the database engine, notable. You want to kind of figure out why that happened, but it may not be end of the world. 19 is some internal limit in SQL Server was exceeded, and the process was killed. That you really want to look at. Once we start getting to 21 here, these are things that we absolutely want to start seeing. It's likely you'll see some things that start to kind of, over time, you start seeing these, and then over time you see not just these, but you start to see these others. And if that's the case, that's a pattern. And that's likely that you're having hardware issues, or your workload has changed extremely, and you need to investigate these things. Once we get to 22, though, that's when we've got confirmed corruption. 22, the table or index is damaged. We're actually going to generate that alert today. That means one of your tables or an index on that table is not in a good spot. The physical structure has been damaged and you need to take action. 23 means that you've got a much larger issue. Typically 23 will fire when you have corruption in the pages in such a way that it impacts the database's ability to function. For example, page free space corruption where the system pages that track free space are corrupt. Or your index allocation maps, there's corruption there. It's not the data itself, but SQL Server is going to have a harder time figuring out what extents belong to your table. Oh, sorry. And then you get things like media failure. 24 and 25, you most likely have hardware that has failed. And if you don't have corruption, you absolutely will get corruption if you don't deal with it. Okay, let me close this out and go back to the other one. And let's head back here. All right, F5 that. So those are SQL alerts, agent alerts in a nutshell. Now, though SQL agent alerts will fire off anytime that a correct page is touched. But there's another thing that happens. There is the suspect pages table in MSDB. Now, this is msdb.dbo.suspect_pages. And this is an interesting one most people don't even realize is there. This keeps a log of every page that SQL Server thinks is corrupt. In other words, we want to see 0 pages in here. 0. If there are pages in here, we can monitor this, or if there are rows in here, we can monitor this table. Say, oh, there are some rows that weren't there last week. Fire off an alert. Someone needs to look at this. And I'll show you an example of that. Let me find, there it is. So if I go here to the bottom of all of these guys, and I just go select star from msdb.dbo.suspect pages. You're going to see I have entries in here. Now, the reason I have entries in here is because I've actually corrupted this database. So it'll tell us database ID, the file, so we can figure out which physical file it is, and then the page ID within. And you can see that it's encountered event type 2 on the 2 pages, and here's a count of the number of times it has encountered issues with those pages. Now, we'll even see the very last day. So what I like to do is I have a job that just looks at this table. If there are any entries whatsoever in this table, it will page a DBA. That DBA will come and evaluate the situation, and once we're back to a known good state, then they will truncate this table. This table doesn't clean itself out on its own. The reason this table is in MSDB and not in master is because it is actually supported to truncate this thing. So, suspect pages is really easy to wrap your brain around. Having multiple ways of kind of getting alerted to this, to corruption, is a good thing. Because what happens if I come out and I shut down agent and forget to turn it back on, right? Well, agent's not going to run CheckDB, right? But I can have some process that runs outside of agent check it for me. All right, so if I go back here, let's get into the real heart of what we're going to discuss today, and that is CheckDB. So this is our main tool for catching corruption. Anyone here not running this weekly? just let me know in the chat and I'll come back to those responses in a minute. So I hope you're running it weekly. I really do. If you are not, you are doing yourself a disservice. And with the way licensing works these days, there's no excuse not to. A lot of times the reason that I hear people say that they don't run CheckDB is that it uses too many resources, it's a hog, it takes too long, and, you know, all right. You know what? I hear you, but here's the thing. You can run CheckDB after you restore the database onto another system, right? You can create a system that all it does all day is restore your backups and runs CheckDB, right? And you can do that without it counting as work. Work is defined by the SQL Server licensing guide. CheckDB is not work, nor is a restore operation if you have software assurance. So really, there's no excuse. You can run it. FYI, I did just get a message. My internet connection is unstable, and it went away. So
Your video froze for just a moment and then came right back. So I think you're okay.
I can tell you what happened. Actually, my internet at home failed over.
I love technology.
This is a server rack behind me, and I have two internet service providers connected to it. So, yeah. So, anyways, there is zero excuse not to run CheckDB weekly, and you don't have to run it on your main system. So, yep, and Peter Shore makes a great comment. He says offloading the CheckDB to another instance via backup will likely satisfy audit requirements to confirm and restore. It absolutely will. So now you're making your auditors happy. You're making the business happy because you're giving them their performance back. And you're doing an end-to-end test if you send that to another data center. So, for example, take your backups, send them off to your DR data center, have a system there that just watches the folder where the files come in, picks them up, restores them, runs CheckDB. If there's no output, it removes the database, and you've done an end-to-end. So you're great. Now, I know we're kind of skipping ahead in a little bit because this was the next slide. But I think that that brings up a few more things that we should discuss before we go back into demos of CheckDB. As I've just said, a backup is no good if you do not fully restore it. That does not mean restore header only. You know, you can trust, but you must verify. Also, I've heard a lot of folks say that SAN snapshots replace SQL Server backups. This is not patently false. This is patently false. They are not backups. They may or may not restore your database properly, and oftentimes your database may come up suspect. Things like Veeam, for example, if your sysadmins are telling you that Veeam is all you need, they're lying to you. Make them do a restore. Have them take their backup while you've got a heavy transactional load running. You know, a few thousand transactions per second is probably all you really need. Have them take their snapshot in the middle of that and watch what happens when they try to bring it up. Your database will come up in suspect mode in all likelihood, and you will end up having to rebuild your log file, which means you lost any data in the log file. Anything that wasn't already hardened to the data files. Other things I've heard are clusters and availability groups replace the need for backups. This is also patently false. And I love HADR. It's one of my favorite topics, along with corruption. But they are not. I have seen where different replicas, some of them were corrupt, others were not. And then that corruption spread. Now, generally what happens is SQL Server will try and say, oh, I think this database page is corrupt. I'm going to try to reach across the AG and grab a clean copy of that page. But that doesn't always work. I can create, using a hex editor, a database with a corrupt page on a secondary replica. I can corrupt the secondary without SQL Server being any the wiser. Then I can take that and say, oh, there's an issue on the other side. It tries to restore that page and it gets the corrupt copy. It doesn't always catch it. Additionally, if you're using something like an FCI, failover cluster instance, which I would have to ask why in this day and age, but also those share storage, right? That's shared storage. So that's not going to save you in a corruption scenario. Point of telling you all of this is you're going to have to deal with this at some point. And somebody is going to say something to you thinking it's some sort of gotcha or whatever, and they're wrong. Veeam and other companies, SAN providers, they often will tell you that their product replaces your need to do these other backups. But at the end of the day, they're not the ones responsible for their data, or for your data, sorry. You are. It's not your sysadmins who are going to get fired if their product restores as corrupt, right? If they restore your database as corrupt, it's you, because it's your responsibility. So now that we took that little side tangent that wasn't really a side tangent, let's get back to CheckDB. CheckDB can do more than just help us monitor and diagnose corruption. It can also help us repair it, but with caveats. And usually there are better ways to repair corruption. Some people come in, and I've seen some terrible advice. There's this option called repair allowed data loss. And there used to be an article out there on the web written by someone who said, if MSDB goes corrupt, run CheckDB with the repair allowed data loss option. Now, that option is a Hail Mary. We're saying that do whatever you have to do to get this database into some form of a usable state. But here's the other thing. It doesn't allow you to confirm what it's going to do or not. It figures it out, it does it, and it tells you nothing. You have no way of going back, seeing what was lost, if anything. So you're dead in the water, right? Think about this unlikely but possible scenario. Say you have a critical job that has multiple steps in it. And each of those jobs are configured such that they will go to the next step. Or each of those steps are configured to go to the next step on success or failure. But there's some sort of dependency there. So your first step runs, with success. You've run previously on this database, you've run repair allow data loss. What you don't realize is that repair allow data loss has removed a job step. And it happens to be a critical one before the data is sent off elsewhere. So the first step runs, it goes to run the next step. Well, the next step is actually the third step because the second step disappeared. How bad is that? Depending upon what that second step was, it could be really bad or it could be totally fine, right? That's very unlikely to happen. But if you ran repair allow data loss, you have to assume it could have happened. It could also remove information related to service broker configurations, or even the agent configuration itself, or any number of other things. So by running this, you're really shooting yourself in the foot. And even though I've handled a lot of corruption issues, I've only had one case where I've ever had to run this, and Microsoft told me to do it. Never run that option unless you have been told to by Microsoft themselves. And I'll explain in a bit where and why that option I was told to run. It was a very specific scenario. And above all else, do not trust what you read on the internet. So let's go to our window here and let's look at CheckDB and understand how to read it. So down here, we have a database that I have pre-corrupted. And we're going to check our corruption demo database right here. If I run this, we'll see that it takes a little bit. It gives us some output. Now, if I had done general demos over here, it outputs nothing. And the reason for that is we have the options with all error messages and no info messages. So no info messages gets rid of all the junk, and all error messages make sure that you see every actual error. And this table results is actually an undocumented option. And it just normally, if I go back, I'll show you how it outputs. Without that option, when we run CheckDB, we're going to get it in a format like this. With table results, it's going to present it to us in an easier to read format. Now, the first column here gives us details about the object, what index, partition, allocation unit the error occurred in, and will tell us the actual error message. We'll come back to that one. The repair level here is a liar. Never trust the repair level. It's completely wrong half the time, or 90% of the time. Right? We'll see the database ID. We'll see a lot of the information we have from here broken out into here to make it easier to digest. This is why I like to use table results. It'll even tell us the slot in the page, right? So it allows us to get in real close. Now, if we copy one of these guys out so that you can actually read it, right? We see that we've got all the same information here. And we get a little more. So I'm going to bring this down here, bring that up here. And here tells us what's going on. Page 1329 was not seen in the scan, although its parent 1360 and previous 1328 refer to it. So something has gone on with this page. It's broken. Now, anyone see anything interesting about listed in here? I'll give a moment for people to read this over and let me know. I'm pretty sure David has spotted it already, and I'm pretty sure Rick and Peter probably have spotted it already. What can we learn from this information? Correct. We learned that it is a non-clustered index. So we have our object ID here, but we also have our index ID. And an index ID greater than 1, so 2 or higher, is a non-clustered index. And the thing is, with a non-clustered index, that's not the actual data in the table itself, right? A non-clustered index is a secondary object associated with the heap or clustered index. So, how would we fix this without doing a restore? Any suggestions from anyone besides David? Yep, drop and rebuild. That's all we have to do. It's a non-clustered index. We'll recreate the non-clustered index. It'll read all the data from the primary and it will fix itself. Now, in this case, we have 2 errors relating to this. Right? So if I copy this other one, and I'm going to show you why this thing lies. So it did a test on the page, and it saw it was off. And then look right here what it suggested for repair level. Repair allowed data loss. This is the same page. It's still 329. So someone coming in and seeing this for the first time, CheckDB itself is telling them to repair with allowed data loss? That's just crazy. Why would I run that when I can just rebuild my non-clustered index? And the problem is, in a lot of cases, even with different types of corruption, it makes the same recommendation when you don't have to. So if you're doing this at 3 in the morning, the likelihood of you running this option is a lot higher than you think, and it's the absolute wrong thing to do. So what we're going to do is we're going to disable the index, right? We are then going to rebuild the index, and then we're going to run CheckDB again. We've resolved the corruption. So what we're going to do is we're going to hire from now we've selected out of the table. We've gotten all our data. But let's go back up here and do msdb.dbo.suspect pages. Our data is still here. We've resolved the corruption. So if we had a process that monitored this, we might need to clear this out. So we could do truncate table. And boom, now we can monitor again. and just see if this has a single row in it. You don't even need to select the actual data out. You could have your query just be exists select 1. So now we've modified some of our now we know how to go in. We have an idea of how to read the CheckDB output. We understand that it lies to you about repair level needed. Let's talk about an issue where I did have to run repair allow data loss. And that was, we had one of our page free space pages go corrupt. And what happened with that was, okay, it's a page free space. It doesn't contain any data. So we're going to add a new file and we'll empty the data out of the old one, and that'll resolve it. That worked great until we got down to the last couple megabytes of data. The ones that were referenced by those broken PFS pages. And so we couldn't pull out that last bit of data. So we opened a support ticket with Microsoft to get options. And what they actually said to us was that we could run repair allow data loss, and that would fix that PFS page and allow us to get the last bit of data out. And they were right. It did. But here's the thing. Now we had all the data in a clean database where we could read everything from, but it wasn't clean. It wasn't truly clean. I shouldn't have said clean. Because we had run repair allow data loss, we can't trust that database anymore. So we created a whole new database, and we pulled all the data out and into the new database, and then just dropped the old one. If you run repair allow data loss, Microsoft can find out, and they don't have to support you. And I don't blame them. Do not run repair allow data loss unless they tell you to, please. All right, so let's talk about incident management, because, you know, as I mentioned at the start, the first time you deal with corruption, it's likely going to be early in the morning. And how you respond to it determines how you can avoid missteps. So, what does a good incident management process include? Well, it usually involves having something like an incident commander, someone whose job it is to handle the coordination for the incident. They are someone that you would reach out to, or they would reach out to you. And from then on, they handle communication. They handle a lot of things. Their job is to allow you to focus on your part. They will wake people up for you. And usually they're a manager and they have the authority to wake people up for you. This is also called a manager on call, because usually the commander is whoever's week it is, determines who it is. They're also responsible, generally, if it's a full-time position, for having thorough documentation about all the systems, etc. This should be maintained no matter what. So if it's an on-call rotation, it's all the manager's responsibility. But these should contain not just contact info, but policies, SLAs, and run books for dealing with certain incidents. You know, things that are known or expected. They should also be leading the call to document any incidents that haven't been encountered for, so that you have a run book for it. And then once the issue is done, they've kept everyone on track, they will often oversee a post-mortem process. So a post-mortem is written after the fact. It describes the incidents, what happened, why it happened, what the resolution was. I like to use a methodology called the 5 whys. So why did the database go corrupt? It went corrupt because of an issue with storage. Its access to the storage was lost. Why was its access to storage lost? Because the SAN controllers were not available. Why weren't the SAN controllers unavailable? Because one of the controllers was down and was being replaced, and the other controller failed. Okay, now we have an idea of root cause. You'll notice we didn't even get to 5. Often you only get to 3. So that immediately tells us an action item we can take, right? Add another controller, perhaps. It will likely also raise questions on the storage team side. Why did both controllers fail so closely together? Because, well, they were old, hadn't been patched in 2 years. Well, okay, that's a whole separate incident now, but it's not one you as a DBA have to deal with. But very quickly we find out what team should be handling this, right? It's very clear in that scenario I just went through what team should be handling this and what they need to do. Now, I worked at a company where we had this guy who did this great thing. Every quarter we met to go over all the incidents, and it would be all the leads. So we'd all be there. We'd look over every postmortem that had been done, and we would have to explain why the action items on there weren't done. You got to do that once. You got to delay for a quarter once. If you tried that twice, you were walked out of the building. You did not have a job. They took it very seriously, and things moved fast, and we got resolution. The other thing that postmortems help with is providing metrics, right? We can track incident types. Are they increasing? Are they decreasing? How are we doing overall? It gives us those KPIs. So incident management will help guide you through the process. Now, let's talk about dealing with corruption from our standpoint. So the first thing you want to do when corruption happens is freak out. Don't do that. Take a deep breath. Your next thing will be to call your incident commander. If you don't have an incident commander, then it's up to you to inform your stakeholders. Right? What you're going to do is you're going to get everyone into a Zoom or whatever so that discussion and planning can take place. Whoever the system owner is, I feel like if there is no official incident commander, it's their job to lead that discussion. But here's the hard part for DBAs. Don't react, right? Take a step back. Your job at this point is to put together data for the stakeholders. You do not make decisions yourself. If you cannot convince the stakeholders of your course of action, don't do it. Period. At the end of the day, they, as the owners of those systems, need to be the ones making the decision. Otherwise, you will have a resume generating event, an RGE. Right? But if they decide to go down a bad path and they make the mistake, they own it. And they will learn from it, and they won't make that same mistake again. But as a DBA, don't go rogue. So the first thing you want to do when you start investigating is you want to ask a few questions. One, is it going to be faster to restore than to try to fix? I hope you've all got point-in-time restore capabilities. Second is restore your only option. Some types of corruption, that's your only legit option, like boot page corruption. What's your RTO and your RPO? You need to understand these things and understand if you can get where you need to be in the time allotted. You need to look at any errors and alerts. Are you part of an availability group? Is there an option? Do you need to fail over to work on that database? All right. Could you just reseed? Right. All this to say, you need to understand your timelines and your options here that are not getting in there and trying to repair this thing. All right. What's your fastest path to resolution? Then you work this in as a group that, as I said earlier, stakeholders make decisions, not us, right? We've already kind of gone over this as we've gone. Most of these last few slides are for you to go over, so we're going to skip them. But if you follow these steps, you'll be in a much better place. You will find that you're less likely to make mistakes. You're not going to be beat up by your company for making the wrong move, right? If you know how to monitor, you know how to deal with corruption, your life is going to be much easier. And 9 times out of 10, your answer is probably going to be restore from backup. But in every case, there will be a follow-up to find out why it went corrupt in the first place. So that's pretty much everything I've got in the time allotted here. So I guess any questions?
I don't see any new ones in the chat window, but if anybody has any questions at all, please throw them in the chat window, or honestly, just come off mute and ask.
Yeah.
There we go. Is there a way for ourselves to check if repair allowed data loss was ever run on any DBs? He's thinking about any inherited SQL Server databases that he doesn't have the full history for. It's a really good question.
So interestingly enough, if I go back here and I go to new query, is it file header? Hang on. DB info is what I think it is. If not, I'll look it up. But we need a trace flag for it. And I always forget the syntax of this, but
I think that looks right.
Yeah. This is a shortcut. This is an undocumented command that is a shortcut for DBCC page. But what's interesting is we're looking at the boot page of SQL Server. So find what we'll set our thing. Let's just search for good. Okay, let's search for last. All right, it's searching up in here, I think, instead of down here. So, here it is anyways. If you look at this, it'll tell you the last time DBCC was run. And it will tell us, at least the last time it was run, that it was good. In regards to your specific question, however, no. That is not exposed to us, but Microsoft can view it because they understand exactly where it's hidden. So
That'd be an
the answer to your
interesting.
question is no.
Yeah, that'd be a really interesting one if they would actually expose that. That's
I would love for them to expose that.
what do we need to do to talk to some
So
folks that we know to get that in there? That's really interesting.
there's also other things that I would love for them to include, like the ability to force a replica to force itself out of the out of an AG and stop any undue operations that are running.
Yeah, that'd be a good one.
But yep, I mean you can see a lot about your database from here, and also this accepts table results too. So
See the question
this,
from
by the
Ted
way,
in
is
here.
the single most important page in your database.
Yeah.
All right, what's that?
So the comment is, quote, I don't have much exposure to SQL Server in my day job as a data analyst. I'm wondering whether failback could be, quote, done in a laptop with 20 free gigs of disk space. I'd like to know how to properly learn this failback or issues from SQL Server without having a development or production environment. To be able to replicate this, you don't need much hardware at all. I mean, literally, SQL Server Developer Edition
No.
installed on virtually anything it'll run on would give you the ability to test this. If you contact Brandon or I separately, and feel free, send me your, if you want to DM me your email, we can contact you. We can show you how to corrupt a database. And there's a couple of undocumented things. There's a few things out there we can do. And it doesn't have to be a big database, doesn't have to be anything big at all. And you can simulate and test this to no end on, I mean, literally, you could do it on phone if you can get SQL Server to run on it.
With the caveat that you only will run those commands in a isolated environment that is not part of any employer's environment.
Correct. It's purely for learning. I do this a fair amount. I will actually show people in a completely isolated development environment how to corrupt a database so they can practice repairing it.
You can also, Steve Stedman has pre-corrupted databases and challenges that you can do along with the solutions to fix them.
Yes.
If you really want to practice, download those. They're free for the community. You don't have to corrupt them yourself. And they're not going to require much hardware at all.
I'm throwing the link in the chat window right here for you. That
Julian
actually
just did.
Perfect. I missed it at the same time. That's great. Thank you, Julian. That is wonderful. Yep. These are it's critical. You're going to encounter this stuff no matter what. So let's do this. Yep. I'll send you an email, and thank you for sending me your email. I'll send you this, and I'll add Brandon on there. This stuff is important. I appreciate you wanting to test this stuff to learn how to recover from it. So that's really cool.
Yeah. And even as an analyst, I think that you have a role to play, right?
Yeah.
You can help define proper policies and procedures around this stuff. You can help coordinate people to make DR testing and corruption testing a yearly or bi-year, twice a year thing. Yeah. And that's going to help everyone out.
Because this stuff happens. It's desperately needed. And you would be amazed at the number of IT pros out there, people with decades of experience. You hand them a corrupt database, I mean, it's literally just finger in the nose, and they don't know what to do.
Yep.
Awesome.
And they don't often have a desire to learn either. They just want to forget about it when it happens.
Yep. It's rather interesting. I can comfortably tell you my U.S. Thanksgiving was wrecked last year because I did 40 hours in 3 days to try to recover a corrupt database.
Yeah. And to be honest, there's a hidden message to this presentation as well. That is, backups are important.
Restores are even more important.
Your backups can propagate the corruption. So
And my personal favorite is when people don't watch for the stuff and you end up with a corrupt database and they start restoring old copies and it was corrupt for months. It's literally aged out and now
yep,
embedded.
yep. I get those calls occasionally,
So do I.
and I charge a you should have known better tax. The if
Rightfully
they have an
so.
actual DBA, I charge. If they have an actual DBA, I charge the you should have known better tax. If they don't have a DBA, I charge the you need to hire a DBA tax.
I like that.
Right. At least get your environment audited like once a year or something by someone who knows what they're doing to kind of get you to where you need to be, right?
And set up basic alerts so that when these things happen, you're notified immediately.
Exactly.
Yeah. Awesome. Are there any additional questions or thoughts or comments? There you go. One more. Would you recommend to set up monitoring on suspect pages, or is that covered by the alerts? I would do both. Because
Yeah.
with
Oh,
this
I'm
scenario,
paranoid. I'm a DBA. I do
yeah,
both.
yep. I do both, and this is
I mean, it means you're going to get double paged, but it also means you're getting double paged, so you know it's serious.
Uh-huh. I can deal with a double text. No big deal, because this is big. And this is a don't finish your supper, don't go out to the movie and then come home and look at it afterwards. This is literally drop everything, don't pass go. You're going straight to the terminal to try to figure out what to do about this.
Yep. Pull over onto the side of the road and use your hotspot to log in. Don't do it while driving. Pull off the road.
You can do it while somebody else is driving. How's that?
Yeah. If you have that, yes.
Yeah. Cool. Well, with that, I think we are good. So thank you, Brandon. And for anybody watching this after the fact, do not hesitate to reach out and contact any of us if you have any questions on the presentation. This video will be up on YouTube by the end of the night tonight. So thank you, Brandon. Thank you, everybody, for watching. If you're watching this after the fact, thank you for actually caring, because, the stuff is important, but you'd be amazed at the number of people that we see with apathy out there on this topic. So thank you all. And I look forward to seeing you all at the next one. Next month, I think we're taking a bit of a break because next month is the PASS Community Data Summit, but we'll be back at least once, if not more than once, in December, and we'll get rolling. So thank you all.